Hey, welcome back to the second part of the review for Test 3 coming up in Math 110 in the online class for the fall of 18. I believe we left off at question 6 last time, and we're going to start off with question 7 now. And question 7 reads the following. Make sure that this is showing. In a random sample of 60 dog owners enrolled in obedience training, it was determined that the mean amount of money spent per owner was $109.33 per class. Assuming the population standard deviation for the amount spent per owner is $12, construct and interpret a 95% confidence interval for the mean amount spent per owner for an obedience class. Now, it's always in the last sentence that they try to clarify what you should be trying to find in the question. And what they say here in that last sentence is, or in the last part of the sentence, construct and interpret a 95% confidence interval, so that tells you it's a confidence interval, for the mean amount spent per owner for an obedience class. So it's telling you to find the confidence interval for a mean. But in that circumstance, what you have to know is, are you going to use a z interval or a t interval? As I mentioned in the first video, the distinction between using a z interval and a t interval typically comes down to whether or not you're provided with a population standard deviation. And in this question, it says quite clearly that the population standard deviation of the amount spent per owner is $12. So since they are very clearly providing you with a population standard deviation, we're going to use a z interval for this one. So let's record what it is that we know in this question. So in the question, we know from the sample mean is going to be 109.33. We know the population standard deviation, usually that's going to be from other studies, is going to be equal to 12. And it wants us to construct a 95% confidence interval. So the confidence level of this is going to be 0.95. And let's see, we have 60 dog owners, so n is going to equal 60. Forgive the bell, have to put up with that while we're doing this here. So if we're doing this on the calculator now, we're doing a question like number 7. What we're going to do is we're going to go to turn that on, hit clear, stat, I'm going to go to test. And for this one, because we know the population standard deviation, we're going to use the z interval. And because they're giving us all the major data, like for example, population standard deviation, sample mean, and so on, we're going to make sure that the stats portion of this is highlighted. So let me kind of show that over here. And let me sure not to have too much glare. So we're going to have a z interval, stats. The population standard deviation for this one is going to be equal to 12. X bar, let me go ahead and type that in here. The sample mean, that's going to be equal to 109.33. The n value, the sample size is going to be 60. The confidence level is going to be 0.95. That's already included here. And then we're going to go ahead and calculate, and we're going to get the confidence interval. And in this case, it's going to be 106.29 to 112.37. And this is written as it's going to be in the question. And if we're looking at the question, it looks like it is going to be, should be choice B. And I'll double check myself to make sure that that's correct. And it is. And if we look at choice B, notice here it has the correct confidence interval, and it also has the correct statement where we say we are 95% confident that the mean amount spent per dog owner for a single obedience class is between $106.29 and $112.37. So that's how that's going to be done with the graphing calculator. So that's question 7. So these are the kind of steps you may want to include on your cheat sheet because it is easy to confuse these things sometimes. Let's go ahead and take a look now. Flip this over and begin to take a look at question 8. Let me rip this out. In question 8, it says to construct a 95% z interval on or a 95% t-interval about a population mean. Assume the data come from a population that is approximately normal with no outliers. So they're giving you data. So in this one, we're actually working with data. So this is unlike other problems that we worked with before. So it says here the height of 20 to 29-year-old females are known to have a population standard deviation of 2.7 inches. Now, just pause there. This couldn't possibly be labeled more clearly as a population standard deviation, which means you're going to treat it as a z-interval because the population standard deviation is known. A simple random sample of 15 females, and again, they're being very clear about this, from 20 to 29 years old is given in the following data. So they're giving you this data here. And what do they want you to do? They want you to construct this interval about the population mean. So we know it's going to be for a confidence interval. So if we're given data here, notice what they're not giving us. They're not giving us the sample mean. So there's some data that they're not providing for us because we can type this in and work with it. So how do we handle it on the graphing calculator? So we're going to go to Stat, and we're going to press Edit. And you'll find, based on the work I already did on this question, I placed this list in L1. Okay. Now, for some reason, if you don't have L1 on your calculator and you need to utilize another list, you need to account for that when you're doing the calculations, because L1 is kind of the default list that will appear in your calculator if you're doing it. So you make sure that list is in there. Make sure everything is typed in accurately, because if you have one thing that's not typed in accurately, you're going to get a different answer than what's in the multiple choice. Once you do that, we're going to go to Stat again. We're going to go to Tests. We're going to go to z-interval this time again. We go to z-interval because we know what the population standard deviation is. And that should be choice 7 in your calculator. This time, because we're not provided with like the sample mean, because we're given a list of values, we're going to use the data portion of the calculator. So I'm going to press Enter. And what you'll notice on your calculator is that it changes what's required to be shown significantly once you highlight that data piece. So let's move this over here. Hopefully everyone can see that. So this is going to be a z-interval. Okay. The data is going to be the input this time. The population standard deviation from this question is going to be equal to 2.7. So I'll put that in. The list where I'm getting the information from is going to be L1. So I mentioned before that that's the default. So for some reason, if you don't have L1 on your calculator, you need to change the list. The way you can change the list on this is to just type in, let's see, if I highlight this, I go to second, and then if you go to the 1, 2, or 3 key, you'll find in the upper left corner of each key, it'll say like L1, L2, L3. So you hit second, and then you can just hit like 2 to highlight L2. But I'm going to go back and I'm going to put L1 because that's where my information currently is. The frequency, you're just going to leave as 1. That's the default value. Just make sure that continues to appear as 1. And the confidence level in this question is 0.95. So, and I'm going to put this as confidence level, 0.95. And I'm going to press Calculate. And it's going to provide me with a couple things. It's going to provide me with what my the confidence interval for this. It also provides me with the sample mean, which is often something we would use to help form the confidence interval. So that's going to be given here. So what do we get for the confidence interval here? We get 64.98 to 67.713. That's what the calculator generates here. And let's see what our answers show. So we have, see, 64.98. That looks like a good candidate. Probably going to be choice A, the 67.72. Now, if you take a look at this here, the 67.72, this varies just slightly from what we got on the calculator here. Now, this does happen occasionally, and the reason for that is because when you're using graphing technology, it works with a higher level of accuracy than the data values that you use when you're working with tables to do the calculations. But A in this question is still the correct choice. Hold on. Sorry, yeah. So A in this question is still the correct choice for question 8. And we want to say we are 95% confident that the mean height of 20 to 29-year-old females is between 64.99 inches and 67.72 inches. Okay. And I would imagine that probably, I don't know if that's an international study, if that applies within a particular country, but that's certainly the case here. Okay, let's take a look at question 9. The null and alternative hypotheses are given. Determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed, and the parameter that is being tested. So in the null hypothesis, a couple of things you need to know about the null hypothesis is with the null hypothesis that the null hypothesis will always include equality. So you're never going to have an equal sign in the alternate hypothesis. So when you determine the tail of the test, it's usually going to be determined by the information provided in the alternate hypothesis. So if the null says that mu is going to be equal to 0.95, and the alternate says that mu is not equal to 0.95, well, by saying that it's simply not equal, that could mean it could be higher than 0.95, or that it could be lower than 0.95. So let's consider what these three options would look like, because you may be asked this question in any one of three variations on the test. So let's consider one alternate that mu is not equal to 9.5. Okay, from the standpoint of this, let's say we're going to have 9.5 here. If mu is not equal to 9.5, it could be significantly higher, it could be significantly lower than that. In that case, then, we want to consider where would be a value that we would consider significantly higher, or where would be a value that would be significantly lower. So because we want to keep both values open, we would consider this a two-tailed test. So in this particular question, choice B is going to be the answer. But I don't want to simply stop there because I want to consider other alternative hypotheses. So let's consider another alternative hypothesis. Let's say we said that mu was going to be greater than 9.5. Well, if we're looking at that possibility, then what we want to know is how much higher than 9.5 is it going to be? So we want to consider as if it's significantly higher, then what is the critical value that we need to go above for 9.5 to determine how much higher is significantly higher, such that we would end up rejecting the null. So when we have the case of this being greater than 9.5, we would consider this a right-tailed test. Now, so this is an example of a right-tailed test. One strategy to think about is kind of a quick way. You should understand this, but if the alternate hypothesis has this pointing to the right, this will usually indicate the tail of the test. Since this is pointing to the right, we would say that this is a right-tailed test. Let's compare this with the other possibility. So this is not equal. This is greater than 9.5. Here we'll say that mu is going to be less than 9.5. Well, if that's the case, then we'd want to know, based on the normal distribution, how much less than 9.5 is it? If it's like 9.3, well, that's not significant. But if it was like 2.1, that may or may not be significantly less than this, such that we would make a decision to reject the null. But what's that going to be? So you notice here that we would consider this a left-tailed test because we're going to look for the critical value to see how much lower we want to go to determine something if we reject the null or not. So notice here that the inequality here is pointing to the left, and that will help us to determine if it's a left-tailed test. So the quick answer to question 9 is B. However, this is how we determine whether something is a right-tailed test, a left-tailed test, or a two-tailed test. And that's going to be question 9. So let's take a look at question 10. Okay, if we reject the null hypothesis, when the null hypothesis is true, what type of error have we made? Well, this is sometimes students confuse these all the time, so you may just want to have a quick note to yourself. This type of error is what we regard as a type 1 error. So this is an analogy I like to tell students is, suppose you have a significant other, and let's say they tell you they're studying at the library, but you think they may be out drinking with friends. and they try to tell you, oh, no, 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 I was at the library, I was at the library. Well, a type 1 error would mean that, no, they were telling the truth, but you decide to reject their story and say that they're lying about it. That would be a type 1 error. A type 2 error would be when your significant other is telling you, oh, no, I was at the library. You believe it's true, but no, they're actually out drinking with friends. So that's the distinction between a type 1 and type 2 error. So a type 1 error is when the null hypothesis is true, but we don't accept it. The type 2 error is when the null hypothesis is not true, but we end up accepting it. So I don't know if that story helps to clarify things or not, but you probably want to have a little quick note in your cheat sheet to point out the distinction between those two things, because it is an easy thing to confuse. Okay, so that's enough for number 10 there. So hopefully you understand the distinction between those two types of errors. Let's go ahead now to question 11. So it says the mean age of professors at a university is 52.2 years. If a hypothesis test is performed, how should you interpret the decision to fail that fails to reject the null hypothesis? So you fail to reject the null hypothesis. So one thing is that it depends on what the claim is focused on. Okay, so let's look at choice A. Do we say there is sufficient evidence to support the claim that this is true? There is not sufficient evidence to support the claim. There is not sufficient evidence to reject the claim. Okay. So in question 11, we're going to regard the correct choice is there is not sufficient evidence to reject the claim that mu is equal to 52.2. Because one thing when we state the conclusion to a hypothesis test, we're never going to say that we accept the null. You never accept the null hypothesis. Okay, you can reject the null, but you can't accept the null. So the correct choice in this one is going to be C for number 11. Let's go ahead to look at number 12. Actually, I'm going to stop the video at this time, and I will resume third part in a little bit.